Hey guys, welcome to this part 2 video on comparative advantage. In this video, guys, we're talking about input problems. Input problems are situations where the inputs are varying and the outputs are constant. That's right, the inputs are varying. That's when they give you the data in the problem. Oh, the inputs are all different numbers, but the outputs are constant. Now you've got an input problem, and that's what this video is about. The part 1 video did an output problem, and actually they're slightly easier to solve, I think. So I want you to go watch that part 1 video because it explains so much. That was an output problem. Again, this is an input problem. But I am going to go over the basics, so let's do the basics. We're talking about comparative advantage, and we're talking about comparative advantage. Here's what we're talking about. Who should make which good when trading? That's right, when you have a trading situation between individuals, groups, or nations, which group, which trading partner should make which good? And we're not going to make our decision based on who has the absolute advantage, i.e. who is better at something. That's not what we're going to make the decision on. We're going to make the decision based on who has the comparative advantage. Now, the way you can define absolute advantage is the following, okay? And there's two ways to define it. You can say it's the entity that can make more of something with the same amount of resources. So the trading partner that can make more of a good with the same amount of resources, there it is absolute advantage. They're better. And by the way, that definition applies to output problems. You can also define absolute advantage as who can make the same amount with less resources. Who can make the same amount with less resources? That's an input problem. That's what this one is all about. Again, that is absolute advantage. Comparative advantage, when you get the definition of comparative advantage, what shows up in that definition is the other good. In absolute advantage, you never heard about good B. We just said, hey, you got the absolute advantage in the production of good A if you can make more of A with the same amount of resources, or you can make the same amount of A with less resources. You don't hear good B mentioned at all in absolute advantage. In comparative advantage, we say, hey, somebody like Jane has the comparative advantage in the production of good X if when she makes good X, she gives up less of good Y. There's the other good, okay? She gives up less of good Y than the other trading partner. Whoever gives up less of the other good, whoever has that lowest opportunity cost, it costs them the least when they make the good, they're the ones that should make the good. And when this really comes into play is when one of the trading partners is better at both goods. When a trading partner is better at both goods, should we trade? Absolutely. There's still benefits of trade coming our way if we base trade, again, on comparative advantage. Who has the lowest opportunity cost? Okay, so let's get to it. An input problem. How do you solve input problems? They're not quite as straightforward as output problems. Input problems, you gotta do a little bit of work to get to opportunity cost. And the way to get to it is one of two ways. You can handle it as an input problem, or you can change it to an output problem. The first thing I'm gonna do is handle it as an input problem. So just kind of stay with me on this, okay? Here's what we're gonna do. We're gonna say, here's Jane, and I want to get opportunity cost. When she makes one of A, how much does it cost her? So I'm just going to put 1 of A. Put a negative sign opposite the 1. And now I'm just going to look at the data here, okay? Jane, when she makes 1 of A, it costs her 5 days, or it takes her 5 days. We can say it that way. 5 days to make 1 of A. Now here's the key. In 5 days, how much of B could she make? Remember, 1B, it takes her 10 days. So in just 5 days, how much of B could she make? A half. And there you go, you've got it. You've done all truly the hard work, okay? You just found opportunity cost. You can just do proportions now. Divide both by 0.5 or divide both by half, either way you want to say it, right? And that would give you our comparative, our opportunity cost in terms of making one of each good, okay? But I'm going to do it this way. I'm going to just kind of do this little input problem, just make sure we've got it. I'm going to say it like this. I'm going to put 1B, okay? And of course, I could just do a proportion to get this, but I also want you to kind of see how I'm doing this, okay? So when Jane makes 1 of B, it takes her 10 days, right? 10 days to make 1 of B, 5 days to make 1 of A. So in the 10 days to make 1 of B and the 10 days to make 1 of B, right? How much of A could she have made? 2 of A. There we go. We've got it. Opportunity cost. Mary. Here comes Mary, right? Go a little bit faster, right? We put that 1A, negative sign opposite the 1. To make 1 of A, it takes her 2 days. 2 days to make 1 of A. It takes her 6 days to make 1 of B. So in 2 days, how much of B could she make? Only 1/3 of B. Equals, put 1B. All right, I'm gonna do it again. That's a B, by the way. All right, so we're gonna do that again. We're gonna say, look, 6 days for Mary. Mary, 6 days to make 1 of B, right? 6 days to make 1 of B. 2 days to make 1 of A. So in the 6 days to make 1 of B, the 6 days to make 1 of B, how much of A could she have made? 3A. you've got it, you've got opportunity cost, and now you're ready to go. We can just kind of look at this right off the bat. Who's got it for making A? Ooh, Mary has the lowest opportunity cost when she makes A. Mary's got the comparative advantage for making A. When we make one of B, who's got the lowest opportunity cost? Oh, Jane has the lowest opportunity cost for B. So we go ahead and write that A and B. But I'm going to now change this problem, okay? We're going to change this problem to an output problem, okay? What we're going to do here is fix the number of days. Now, it's not that hard, and a lot of people it might take a little bit of like getting used to doing this, but if you look at this data, it should become kind of apparent that a good number of days to fix the data to is 30 days. So you say something like 30 days. Okay, now I'm fixing the inputs, right? In 30 days. Okay, so 6 times more days, 6 times more of A. 6 of A for Jane, okay? In 3 times more days, 3 times more of B, 3B. I hope that makes sense to you. Mary, 15 times more days, 15 times more of A, 15A. 5 times more days, 5 times more days, 5 times more of B, 5B. Put your negative. There you go. That's opportunity cost. And if you do the proportions, you're going to get the numbers we just did. I'm going to go ahead and do the proportions because it looks like I erased it. So very quickly, negative 6A over 3B. Divide them both by 6. I get 1A. 3 divided by 6 is 1/2 B, just what we had before. Divide them both by 3. I get 1B. 6 divided by 3 is 2. Same thing I had before. Over here, I've got negative 15A over 5B. Again, this is opportunity cost. I'm just doing proportion. Divide them both by 15. I get 1 of A. 5 divided by 15 is 1/3 B. Put my negative sign. Divide them both by 5. I get 1B, right? 5 divided by 5 is 1. 15 divided by 5 is 3. This is exactly what I had before. Again, just take a look at it. Who has the comparative advantage when making A? Mary's got the lowest opportunity cost. Hey, that's what we said before, right? Who's got the comparative advantage for making B? Hey, lowest number, that's Jane. Jane's got it for B. Now, before we finish, let's just do a range of possible trade terms, a range of mutually beneficial trade terms. That's my bell. It'll stop in just a second. Here we go. I could do it for 1A or 1B. I'm gonna go ahead and do it for A. So looking at 1A and 1A. So I'm gonna put 1/2 and 1/3. So, the lower number of course is 1/3. So I put the 1/3 B on the left because I'm reading left to right, lowest number to highest number. I like to think of it like a number line right here. So, hey, first number is 1/3. The bigger number is 1/2. So 1/2 B. The 1/3, who is that associated with? The 1/3 is associated with Mary. So I'm going to put Mary. We already said 4A, right? 4A, for good A. She's got the comparative advantage. She should be the seller, right? Seller. And then, of course, the 1/2. The 1/2 is associated with Jane, right? So I'm going to put Jane. Jane doesn't have the comparative advantage, so she's going to be the buyer of 1A. Then I finish it off by just doing these inequality signs. I put right there that, what is that representing? That's representing a possible price, a possible terms of trade. Anything in between these numbers will be mutually beneficial. Here's why. Mary wants B, right? Because she's selling A, so she wants B. Mary without trade could just not make 1 of A. And with the resources it would take to make 1 of A, she could make 1/3 of B. But wouldn't it be great if Mary could go ahead and make 1 of A, go ahead and make 1 of A and sell it for some amount of B that was greater than 1/3 of B. That would be beneficial to Mary. Jane, all right, Jane, what does Jane want? Jane wants A. She's the buyer of A. What could she do? Well, without trade, she could just not make 1/2 of B. And with the resources it would take to make 1/2 of B, Jane on her own could make 1 of A. But wouldn't it be great if Jane could make some amount of B that was less than 1/2, some amount of B that was less than 1/2, and then sell that for 1A? That would be beneficial. the range of mutually beneficial trade terms, the possible terms of trade, the possible price. Again, this was an input problem. I went a little bit fast in it. Go watch the output problem video. Come back, watch the input problem, and you will have this mastered. We base trade on comparative advantage. Who has the lowest opportunity cost? Hope that makes sense to you. We'll see you in the next video.